Zoe is currently a resilient communities and forest coordinator at the Ember Alliance, which is a new organization focusing on prescribed fire, professional fire training, and community wildfire resiliency in Colorado. Zoe also did her master's work at Colorado State University in the Forest and Rangeland Stewardship Department with Camille Stevens-Rumann. And I'll let Zoe kick it off to talk more about that in detail. So go ahead, Zoe. Thank you so much.
Okay, I'm back. Well, thank you for the introduction. It's a really good transition from Sarah's talk because we'll also be talking about subalpine regeneration, but focusing on spruce and fir. Just quickly, I will give a little nod to my master's work at CSU under Camille. I'll really be talking about that project, but right now I'm working for the Ember Alliance, which is a new nonprofit, really focusing on wildfire resiliency and kind of beefing up our forests in preparation for more fire seasons like 2020. So my study area for my thesis work was in northern Colorado and a little bit in southern Wyoming. And the main species, like I said, the main species that I studied were Engelmann spruce and subalpine fir. I looked at fuels and tree regeneration following these major beetle outbreaks that I started looking at outbreaks that started in 1996 up until 2017. And I also looked at regeneration following the Mount Zirkle complex and big fish fires, which ranged from 17,000 acres to 31,000 acres burned. And then I also looked at the co-occurrence of both beetles and fire. And I had the chance to compare these post-disturbance conditions to some undisturbed plots, which is more rare now. I also destructively sampled and aged over 200 spruce and fir seedlings from a subset of these study plots. So this map just shows kind of where I collected seedlings in relation to my overall study plots. And from these seedlings, I aged them and to look at different growth patterns of regeneration following different disturbances. And I also paired long-term climate data to seedling establishment dates to kind of get a look at climatic drivers of subalpine tree establishment. So it's important to note here that the majority of my outbreak and undisturbed plots burned in the 2020 fire season. So many of my 50 outbreak plots will now look a lot like the post-outbreak fire data that I have. So just jumping into some major findings, there was a significant reduction in spruce and fir seedlings in the burn plots compared to outbreak and undisturbed plots. So the sites that I worked in had been recovering for 15 or 16 years post-fire. So there have been quite some time to be seeing such low subalpine regeneration densities. But as Sarah noted in her talk, these systems are slow growing. But in these same sites, there were much greater proportions of lodgepole pine and aspen compared to spruce and fir, and greater densities of both lodgepole and aspen in burn sites compared to the undisturbed and beetle affected sites. And we know not only do aspen and lodgepole have growth strategies that allow them to be prolific post-fire colonizers, but they also can withstand hotter and drier conditions better than spruce and fir. So talking about these compounded disturbances and, looking at the 2020 fires that burned through outbreak sites, a significant finding of mine was that there were similar seedling densities in post-fire sites compared to sites that experienced both bark beetle outbreaks and high severity fires. So because of the severe nature of fires in subalpine forests and the fire sensitivity of these species, almost if not all mature spruce and fir were killed. So because of this, the beetle-induced tree mortality before the wildfires didn't have as much of an impact on post-fire regeneration. So there was no evidence for compounded effects of multiple disturbances on subalpine tree seedling densities. And because many of my outbreak plots burned in 2020, it's safe to say that post-disturbance recovery in these areas will resemble the relatively low regeneration densities found in my burned and post-outbreak burn sites. Just for a little visual, this is a picture of a burn plot from the Mount Zirkle wilderness. This was the Mount Zirkle complex fire, which burned in 2002. And you can see there's very little conifer regeneration. And this is pretty representative of what all of my burned and post-outbreak burn plots looked like. So some takeaways from the seedling work that I did. I looked at a lot of different climate variables, but the main takeaways were the importance of cool and moist growing conditions for successful spruce and fir establishment and survival, particularly in their first few years of germination and growth. So I looked at long-term climate averages from 1958 to 2017, and years with no seedling establishment had above average temperature minimums, which could have led to early spring snowmelt and late season seedling desiccation, as well as low precipitation and high water deficits. So again, just cool and moist growing conditions were correlated with subalpine tree seedling establishment, while hot and dry conditions were correlated with no establishment or seedling survival. So we know that large fire footprints like those created from the Colorado's 2020 fire season reduce live seed sources for post-fire colonization, especially for spruce and fir. As Sarah highlighted, it's really relying on seed dispersal from unburned areas into the burned footprint. And we also know that drought conditions like those that have been increasingly prevalent in Colorado over the past 2 decades are bad for subalpine tree establishment and survival. So again, the post-fire regen results that I have are following fires from 15 or 16 years prior to sampling, from fires that burned 17,000 to like 30,000 acres. So one of the major unknowns that I would like to highlight is if post-fire subalpine regeneration will even reach the densities that I saw following fires like Cameron Peak and East Troublesome that burned, over around 200,000 acres as opposed to 17,000. And also, considering the current and intensifying drought conditions that Colorado is experiencing. It's also unknown what the impact of these large surface fuel loads will be when the surface fuel loads that are caused from, beetle-induced mortality and they're burned on the surface or soil level, what that will really do for tree regeneration. So looking forward and maybe some glimmers of hope, I found in my seedling work that there were some low levels of establishment during years with average climate conditions, which we kind of attributed to maybe some site-specific facilitation. Anecdotally, I saw greater proportions of seedlings under down logs and beneath live tree canopies. So this concept of facilitation maybe can be integrated into some management talks to think about how we could buffer some of the temperature and moisture extremes. Another potential management discussion point could be the use of post-fire planting to encourage subalpine tree regeneration. We really saw that the first couple of years of seedlings were the most sensitive. So possibly planting like juvenile trees could avoid desiccation of these really vulnerable germinants. The threshold effects of hot and dry conditions on these subalpine tree seedlings are also unknown, but maybe post-fire planting and shaded facilitation could be a good place to start management conversations on promoting subalpine forest recovery following this past fire season. And some more major unknowns that remain are how or if natural subalpine species recovery can occur given hundreds of thousands of acres burned and increasingly hot and dry growing conditions. And if no management action is taken, likely we'll see species shifts to more fire resilient species like lodgepole pine and aspen. And that, I'll say thank you, and I will pass it back to Marion.
Thanks, Zoe.
Yeah, thank you so much, Zoe.
So we're scheduled to have a break, but let's have a few questions before we jump off, and if we may, and then we'll take a break and then we'll come back. Does that sound good, Maren?
Yeah, so there is one question in the chat here, and it's what age does a subalpine tree produce a cone crop? Do you happen to know the answer to that?
I don't have a firm age, but I think after 10 or 20 years, it's a bit older. But if someone else knows, please chime in because I'm kind of guessing.
With all these forest ecology professors on here, we better get some answers to this kind of stuff here. It's a basic understanding.
Well, I can add a little bit to it. I think the one thing with like subalpine fir is it can hang out in the understory for a very, very long time. So you can have a subalpine fir juvenile that's like this tall, but 50 years old and not producing any seeds. But so I think kind of the minimum reproductive age, I thought it was like closer to more like 30 years, but it could be off there.
I see Wayne's hand up. Maybe Wayne has something to kick in on that one. We've been dying to get you to say something, Wayne. What do you got to say?
I'm trying to figure out the system here. That's why I haven't jumped in already. I agree that it takes a long time for subalpine fir can last a very long time. Some of the work that Bob Alexander, my predecessor, did at Fraser, and then I did a little informal study to try to verify this, is that spruce trees that were saplings in the understory took about 40 years to reach DBH on average. Now, there's a great deal of variation there, but those studies show that it takes a long time for spruce and fir to reach DBH. And I would say spruce trees are not going to produce seed until they're probably small pole-sized trees, which may be as long as 50, 60 years before they get seed. Lodgepole, I've seen lodgepole produce seeds 8 years of age, and that's pretty typical, I think. And as you mentioned earlier, lodgepole tends to have non-serotinous cones at younger ages. A lot of the old clear cuts that we sampled, even though the seed source was gone, we got fill-in seeding. And the only place that seed could come from was those non-serotinous cones that were on those Christmas tree sized lodgepole regeneration in there. So,
thanks, Wayne. It looks like Mike Battaglia's got his hand up. Maybe we can take one or two more and then we can take a break. Go ahead, Mike.
Yeah, hey, I just wanted to make another comment about seeds. So, there's an age issue, but there's also a density of how many seed producing trees you actually have out there, and then even their height in terms of dispersal. So think about not only how old a tree is to produce, but also how many are there out there and how dispersed they are to be able to actually disperse their seeds on a larger area. So because you could have one seed or one tree producing seed, but that's not really going to turn you into a forest. So just another consideration. I don't know the answer though.
Right.
So
thanks, Mike. Yeah, that's a good point. I mean, the ratios of seeds needed to get to trees is all over the place. I've seen for lodgepole pine between 1 tree per 300 seeds to 1 tree per 15,000 seeds. So, really depends on competition, the amount of predation, you know, what kind of site prep there is. So it's kind of all over to get, and, you know, to kind of get a stocked stand. So